In this problem, we want to approximate the square root of 26 plus the cube root of 25 using a suitable linearization from a function of two variables. Okay, so the idea here is that we don't have a calculator or a computer readily available to be able to plug this in to get the exact number. So we want to just do an estimate using linearization. Before we start, it's good to have a ballpark idea for what this number should be. So notice, square root of 26, it's a little bit more than the square root of 25, so it's going to be a little bit bigger than 5. And cube root of 25, it's going to be a little bit less than the cube root of 27, which is 3. So we think this number should be somewhere around 5 plus 3, so it should be somewhere near 8. That's always a good ballpark place to start. Now we want to see if we can do even better. So the first step in a problem like this is we want to pick a function, f of x, y, that we can use to help us approximate this number. So notice, I'm taking the square root of a number, and then I'm adding it to the cube root of a number. So a simple option for what I can let f of x, y be is the square root of a number, so I'll use x for the number I'm taking the square root of, and then the cube root, I'll use y. Okay, there's different options, but this is the function that makes the most sense given the form of the number we're trying to approximate here. Okay, the next step is that we want to choose a value for x and a value for y that's near the point that we're trying to evaluate. So we're trying to take the square root of x when x is 26, and we're trying to take the cube root of y when y is 25. Okay, so we want to choose a point that's nearby 26, 25 that we can use for our linearization. And we're going to basically, remember, linearization is the same as finding the tangent plane to this function. So we're going to find the tangent plane at the point AB and use that to help us approximate what the value of the function is at 26, 25. How do we choose AB? Okay, we know it needs to be nearby the point, 26, 25, and because we don't have a calculator or a computer and we're just trying to estimate it, we want to pick a point where it's easy for us to evaluate the function. And I basically did this in the very beginning when I did a rough estimate for what I think this number is. I took a number, I said I don't know the square root of 26, but I do know the square root of 25. So let's let a be 25. And I don't know the exact cube root of 25, but I do know that the cube root of 27 is 3. So that's easy for me to do in my head. So let's pick the point 25, 27. Because it's nearby the point 26, 25, this point is going to help us get a good approximation if we linearize around it. Okay, the next step is we're going to find the tangent plane at the point 25, 27. We're linearizing around it. So I have this, we're going to the new board. Here's the function we picked and the point we're going to linearize around. Okay, so take a second, put this on pause. Based what you've learned in class, I want you to find the linearization, it's the same as the tangent plane, to this function at the point 25, 27. Recall, here's the linearization, and so we need to find the partial with respect to x and with respect to y, and we already know the value of the function at 25, 27. We already know that's 8. Remember, that was my original estimate. We're trying to see if we can do even better than just 8. Here's the partial of f with respect to x and with respect to y. And now if we evaluate that at the point that we're linearizing around, so we can see if we start at the point 25, 27, and we just move in the positive x direction, this function is increasing with a slope of 1/10. Then if we just move in the y direction, we can see the function's increasing with a slope of 1/27. So now let's use this. We're plugging this back into our linearization formula, or linearization equation. So we get that this is the linearization around the point 25, 27. So now if we step somewhere nearby, this is going to be a good approximation for the actual value of the function. Okay, so we're going to use this linearization to approximate the original number that we're trying to find. The square root of 26 plus the cube root of 25 is going to be approximately equal to the value on the tangent plane. So the value of our linearization function at 26 and 25. So we get that our approximation is 8 plus 1/10 minus 2 over 27. And we can reduce this. We'll write this as a decimal. As a decimal, this becomes 8.02593. Okay, so that's our estimate based on the linearization. And if you plug it into a calculator, if you plugged in the actual number into a calculator, you'd see that the is 8.02304. So our approximation here was very close to the actual number. And that's it.